Hello, my dear students. My name is Lakshmi Narayana. This is LN brand of chemistry channel. So today we are going to discuss about types of redox reactions. This is lecture number 2 in redox reaction chapter. So now we are going to discuss about types of redox reactions. Before going to the types of redox reactions, so now we have to discuss about first what is oxidation. What is oxidation? Then what is reduction? What is oxidation? Then what is reduction? So oxidation nothing but first in case if you take in terms of hydrogen, in case if you take, then removal of hydrogen, removal of H2, or we call it as a loss of H2. Loss of H2 is called oxidation, or otherwise, then one more, that is gain of oxygen, gain of oxygen O2 is also called as oxidation. Generally we know this. So even in case if you take a reduction with respect to hydrogen and with respect to oxygen. So here addition of hydrogen we call addition of hydrogen, or we call gain of hydrogen H2. Then in terms of oxygen, in case if you take loss of oxygen O2, loss of oxygen is also called a reduction. So what is oxidation and what is reduction in terms of hydrogen and in terms of oxygen we know. Now in terms of electrons, in case if you take, that is a new definition actually. Then loss of electrons is called oxidation. Loss of electrons is called oxidation. This is new term, new definition actually. Then in case if you take reduction in terms of electrons, gain of electrons are called reduction. We call it as reduction. Okay, clear? So now one of the example for the oxidation in terms of electrons, in case if we take, sir, for example, the zinc can be converted into Zn plus 2 electrons. Sir, or otherwise, then sodium, in case if you take Na, then Na plus 1 electron. So this is what we call loss of electrons. Electrons loss hota unnai. Then we call it is oxidation. Then in case if we take reduction, for example, Cu plus 2, by taking off nothing but gain of electrons, then it will be converted into copper metal. Clear, my dear students? Then one more, Az plus, by taking off 1 electron, that will be converted into Az. So here from the ions, metals will be formed by taking off electrons. Gain of electrons we are calling reduction. So loss of electrons are calling oxidation. Right, my dear students? So now if you look carefully, so here one more statement also we can observe, that is, in case if you take here, oxidation state of zinc is 0, then sodium oxidation state is 0 because both are present in the elemental form. When it is present in the elemental form, that we call oxidation state is 0, right? So now from 0 to plus 2, oxidation number 0 to plus 2 increases. Oxidation number increases also called as oxidation. So what I told, oxidation number increases. I will mention there, oxidation number increases. then we call oxidation. Then oxidation number decreases, we call reduction. Oxidation number decreases, reduction. Oxidation number increases, oxidation. So both you have to remember. So all these definitions you have to remember. Just note it, all of you. So then I will come back. Yes, look my dear students. So look my dear students, I told that oxidation nothing but oxidation number increases. Then one more, reduction nothing but then oxidation number decreases. Okay, clear my dear students? I told that oxidation number increases, oxidation number decreases, reduction. Sir, one of the example I will discuss with you. Sir, where is going oxidation, where is going reduction? For example, in case if you take Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. This is one of the redox reaction. Sir, if you observe in this redox reaction, if you observe, sir, here oxidation state of zinc is 0 because it is present in the elemental form. Then here plus 2 oxidation state. Then from 0 to plus 2 oxidation state increases. Then plus 2 to 0 oxidation number decreases, right? Sir, where oxidation number increases, then we call, I told that oxidation. Where oxidation number decreases, then we call it is reduction. Understand my dear students, right? So one more example, in case if we take Cr2O7 minus 2 plus 2Fe plus 2 gives rise to 2Cr plus 3 plus 2Fe plus 3, like this there. It is one of the redox reaction. Observe it carefully, my dear students. Then in this, first we have to calculate the chromium oxidation state. So how to calculate the chromium oxidation state? So chromium, take it as X. Then 2 chromiums are there, 2X minus 7 into minus 2. So each oxygen minus 2. Then 14. Then equals to total charge minus 2. Then 2X, it is equals to, then 14 minus 2. Then 2X equals to 12. Then X equals to 12 divided by 2, that is plus 6. So here chromium oxidation state is plus 6. Then if you take here chromium oxidation state is plus 3. Then plus 6 to plus 3 oxidation number decreases. So that we call reduction. Reduction is happens. Then plus 2 to plus 3 oxidation number increases, right? Then we call it is oxidation. So where oxidation number decreases, then we call it is reduction. Where oxidation number increases, then we call it is oxidation. Then one more example I will give to you, my dear students. Then look at Zn plus HCl gives rise to Zn plus ZnCl2 plus H2. This is one of the reaction. Even it is also redox reaction. So redox reaction. Which are the redox reactions? Sir, in which reaction both oxidation and reduction takes place? ఒక రియాక్షన్ లో ఆక్సిడేషన్ జరిగిండాలి, రిడక్షన్ జరిగిండాలి. అలాంటి రియాక్షన్స్ ని మనం రెడాక్స్ రియాక్షన్స్ అంటున్నాం. సో హౌ ఇట్ ఈస్? సో లుక్ ఎట్ ఇన్ దిస్ రియాక్షన్ ఆక్సిడేషన్ హ్యాపెన్స్, ఆక్సిడేషన్ జరిగింది. దెన్ రిడక్షన్ ఆల్సో హ్యాపెన్స్, రిడక్షన్ జరిగింది. దెన్ వి కాల్ ఇట్ ఈస్ రెడాక్స్ రియాక్షన్. దెన్ ఆక్సిడేషన్ ఇస్ హ్యాపెన్స్, then reduction also happens, then we call it is redox reaction. Oxidation జరిగిందని ఎలా చెప్పగలుగుతా ఉన్నావు? Where oxidation number increases, particular element, for example here chromium, then chromium, particular element, oxidation state decreases, then we call reduction. Sir, Fe oxidation number here plus 2, then here plus 3, oxidation number increases. Then if you come to there, sir, copper plus 2, then 0, oxidation number decreases. Then 0 to plus 2, oxidation number increases, then we call oxidation. So ఒక రియాక్షన్ లో ఆక్సిడేషన్ రిడక్షన్ రెండు జరిగితే then we call it is redox reaction. Understand, my dear students? Right. So look at, even this is also one of the redox reaction. So in this redox reaction here, zinc 0 is the oxidation state. Then if you come to there, so X minus each chlorine minus 1 oxidation state, 2 chlorines are there, 2 minus, then equals to 0. Then X equals to plus 2 oxidation state, right? So Zn plus 2 oxidation state. Then here hydrogen in case if you take, then plus 1 oxidation state. Then if you come to hydrogen here, when it is present in the elemental form, any element, when it is present in the elemental form, oxidation state is 0. So that's what I told, hydrogen oxidation state is 0. Then plus 1 to 0 oxidation state, plus 1 to 0 oxidation state, oxidation number decreases, then reduction takes place. Oxidation number increases, then oxidation takes place, then we call it is redox reaction. It is redox reaction. So that is where oxidation number increases, oxidation, where oxidation number decreases, reduction. Both simultaneously takes place within the reaction, we call it is redox reaction. Clear, my dear students? Right. So now one more point how to remember. Oxidizing agent. Oxidizing agent. Oxidizing agent. So the reagent or reactant which is oxidation takes place, sorry, which is reduction takes place, which brings the oxidation, which is reduction takes place. What I told, oxidizing agent nothing but the reactant which brings oxidation, which brings oxidation or which reduction takes place. ఏదైతే రిడక్షన్ జరిగిందో, which reduction takes place, which reduction takes place. సరే, ఏదైతే రిడక్షన్ జరిగిందో, reactant which brings oxidation or reduction takes place, ఏదైతే రిడక్షన్ జరిగిందో, then we call it is oxidizing agent. So here, my dear students, if you take H plus, then from here to there, what happens? So from here to there, reduction happens. Which reduction takes place? Then we call it is oxidizing agent. This is oxidizing agent. Clear? Then reducing agent. What is the reducing agent, my dear students? What is reducing agent? So reducing agent opposite to the oxidizing agent. Reducing agent nothing but which substance or reactant, the reactant which brings reduction, or which oxidation takes place, oxidation takes place. Sir, better to remember, reducing agent nothing but oxidation, which is oxidation takes place. ఏదైతే ఆక్సిడేషన్ జరిగిందో అది reducing agent. Sir, oxidizing agent nothing but ఏదైతే రిడక్షన్ జరిగిందో అది oxidizing agent, opposite. For example, in this equation, look at, observe it carefully. Sir, where oxidation takes place? This is oxidation takes place. Which is oxidation takes place? That is reducing agent, my dear students. Then which is reduction takes place? That is oxidizing agent. Then if you come to this reaction, where reduction takes place, that is oxidizing agent. This is oxidizing agent. Where oxidation takes place, that is reducing agent. So look at, observe it in this reaction. Sir, Zn plus 2, Zn 0 to Zn plus 2. oxidation takes place. Where oxidation takes place, that is act as reducing agent. Then where reduction takes place, that is act as oxidizing agent. Clear? Clear, my dear students? You have to remember all these three equations, note it, and these two definitions are noted. Then we'll come back. Yes, look, my dear students. So next we have to discuss about the identification of nature of the compound. So nothing but, sir, given compound is oxidizing agent or reducing agent or working as both, that we have to discuss. Sir, how we know? Sir, they will ask a question, which of the following is act as a oxidizing agent, or which of the following act as a reducing agent, or which of the following act as a oxidizing agent as well as reducing agent. Such type of questions they will ask. So that only we are calling it as the nature of the compound. A compound ఏంటి అనేది మనం ఫైండ్ అవుట్ చేయాలి. సో అంటే ఆక్సిడైజింగ్ ఏజెంటా రెడ్యూసింగ్ ఏజెంటా అనేది డిపెండ్స్ అపాన్ ద ఆక్సిడేషన్ స్టేట్ ఆఫ్ సెంట్రల్ ఆటమ్. సో వాట్ ఐ టోల్డ్, oxidation state of central atom. So depends on oxidation state of central atom. Oxidation state of central atom. So look at, observe it carefully. We call it as simply Ca. Ca అంటే central atom అనుకుంటున్నాం. Sir, point number 1, these 3 points you have to remember very carefully. Then if you do the applications, you can do very easily. Sir, application number 1, statement number 1, if oxidation state of, if central atom is present in maximum oxidation state, if central atom is present in its maximum oxidation state, maximum oxidation state, so that is working as, so which is oxidation state, that is working as oxidizing agent. Maximum oxidation state, that is oxidizing agent. Clear? Right. Second point, if central atom is present in its lowest possible oxidation state, then it is act as reducing agent. So look at, central atom oxidation state maximum oxidation state అయితే then oxidizing agent గా వర్క్ చేస్తూ ఉంది. Central atom is present in the lowest possible oxidation state, then it is working as reducing agent. Clear, my dear students? Then third one, if central atom is present in intermediate oxidation state, then that is working as, that is oxidizing agent as well as reducing agent, working as oxidizing agent as well as reducing agent. Understand, my dear students? These 3 statements you have to remember. Sir, based on these 3 statements, we can do some of the questions. Sir, just note it, all of you. Yes, look, my dear students, here 2 questions are there. The compound that can act as both oxidizing agent as well as reducing agent. ఆక్సిడైజింగ్ ఏజెంట్గా రెడ్యూసింగ్ ఏజెంట్గా ఏది వర్క్ అవుతా ఉంది అని క్వశ్చన్ అడిగాడు. ఈ నాలుగిట్లో ఏది ఆక్సిడైజింగ్ ఏజెంట్ గా రెడ్యూసింగ్ ఏజెంట్ గా వర్క్ అవుతుంది. Sir, how we know which is oxidizing agent, which is reducing agent? Sir, first central atom oxidation states you have to find out in these. So here first then all these central atoms which are there that I am writing here, look at first one is phosphorus, then second one is nitrogen, third one is sulfur, then fourth one is oxygen is the central atom in it. Clear? So now phosphorus oxidation state, in case if you take minimum maximum you have to know. So remember group number only maximum oxidation state for any element. Group number of nitrogen phosphorus is same, that is fifth group number. So 15th A, 5th A or 15th group we call plus 5 is the highest oxidation state, plus 5. Then lowest oxidation state, how we know? Sir, lowest oxidation state, sir 8, sir group number minus 8 you have to take. Group number is 5, minus 8 in case if you take 5 minus 8 you can take it is minus 3. So minus 3 to plus 5. So lowest minus 3, highest plus 5. Even for this also lowest minus 3, then highest plus 5. Then if you come to the sulfur, sir sulfur oxygen both are 16th group elements. 16th group elements highest oxidation state plus 6, lowest oxidation state group number minus 8, then 6 minus 8, then we call it is minus 2. So minus 2, then minus 2 to plus 6, minus 2 to plus 6. So minus 2 is the minimum, plus 6 is maximum. So look at my dear students, sir highest oxidation state, maximum oxidation state, that is working as oxidizing agent. Sir minimum oxidation state, that is working as reducing agent. Sir intermediate oxidation state, that is working as oxidizing agent as well as reducing agent, right? So here oxidation state of this we have to find out first. Then 3 plus x minus 4 to 8, then equals to 0, then x equals to 8 minus 3, then you can get plus 5. Plus 5 is the oxidation state here. Plus 5 of phosphorus maximum oxidation state, which is maximum oxidation state, that is working as oxidizing agent. This is act as oxidizing agent, my dear student. Then come to HNO2. Then HNO2, sir oxidation state first find out it. Then 1 plus x, then 2 to 4, minus 4 because the minus oxidation state for oxygen equals to 0. Then x equals to, then 4 minus 1, then x equals to plus 3 is the oxidation state for here. So plus 3. So nitrogen minus 3 to plus 5. Minus 3 to plus 5. Nothing but plus 3 is the intermediate oxidation state. అంటే మినిమం ఆక్సిడేషన్ స్టేట్ కాదు, మ్యాక్సిమం ఆక్సిడేషన్ స్టేట్ కాదు, మిడిల్లో ఉంది. సో దట్ ఈస్ యాక్టింగ్ యాజ్ బోత్ ఆక్సిడైజింగ్ ఏజెంట్ యాజ్ వెల్ యాజ్ రెడ్యూసింగ్ ఏజెంట్, మై డియర్ స్టూడెంట్స్. ఇది ఆక్సిడైజింగ్ ఏజెంట్ గా మరియు రెడ్యూసింగ్ ఏజెంట్ గా వర్క్ చేస్తూ ఉంది. దెన్ కమ్ టు దేర్ H2SO3, then 2 hydrogens, then plus x minus 6 equals to 0, then x equals to 6 minus 2, then x equals to 4, plus 4 is the oxidation state, plus 4 oxidation state for sulfur. Then if you come to their sulfur, minimum minus 2, maximum plus 6. Then intermediate, this is plus 4. So plus 4 is the intermediate oxidation state. Which is intermediate? That is working as both oxidizing agent and reducing agent. Oxidizing agent ka reducing agent ka work chesta. Then come to the H2O2. Sir H2O2. Sir here hydrogen peroxide. In the peroxide case, minus 1 is the oxidation state, we know that. So oxygen, in case if you take minus 2 to plus 6, then this is intermediate oxidation state. When it is intermediate oxidation state, even this is also working as oxidizing agent as well as reducing agent. So my dear students, sir, which are both working as oxidizing agent as well as reducing agent? Sir, option B, then option C and option D. Sir, multiple choice question it is. So all these are working as oxidizing agent as well as reducing agent. Yes, come to the second question. identify the nature of the following compounds. So identify which is oxidizing agent, which is reducing agent, that we have to identify. So come to my dear students here, central atoms chlorine, then manganese, then nitrogen, then chromium you have to take. So oxidation state of this you have to find out. So before going to that, chlorine, then manganese, then which is nitrogen, then chromium. Sir, which is the highest oxidation state, which is the lowest oxidation state, that you have to find out. So here chromium in case if you take, so chlorine in case if you take, sir, -1 is the lowest oxidation state because 17th group element 7th, so that is group number -8, then 7 minus 8 -1 you can get -1 2, then +7 is the highest oxidation state for this. Then manganese in case if you take manganese, it will be start from 0 to D black elements, so 0 to, then +1, then +2, then +3, then +4 up to +7, so maximum oxidation state. Then so nitrogen in case if you take, we know that already we are seen there, nitrogen -3 to, then +5 oxidation state. Then if you come to chromium, sir, here even chromium in case if you take 0 to +1, then +3, then +5, then +6 oxidation state it can exhibit. So look at my dear students. Then here chlorine, sir, oxidation state you have to find out X. This is +1, 1 plus X -8, it is equals to, then X equals to +7 oxidation state you can get. Chlorine +7, so +7 is the highest oxidation state, which is highest oxidation state, that is working as oxidizing agent, my dear student. Then manganese, sir, already came in over, we are calculated, sir, manganese +7 is the oxidation state, so which is highest oxidation state, that is working as oxidizing agent. Then HNO2, sir, HNO2 we are already calculated, oxidation state is +3, so +3 oxidation state, so that is intermediate oxidation state. So intermediate oxidation state, oxidizing agent as well as reducing agent. Then come to last one, chromium in this, so that is +6 oxidation state you can get, already we are calculated even chromium also, right, in the previous question. Then highest oxidation state, that is working as oxidizing agent. So these are the nature of the compounds, just note it all of you, then we'll discuss 2 more questions. Yes, look my dear students, here 2 more questions are there. So first question, which of the following can act as both oxidizing agent as well as reducing agent? They're asking question like this. So what we have to do, central atoms of oxidation state, first you have to calculate which is the highest oxidation state, that is act as oxidizing agent, which is the lowest oxidation state, that is act as a reducing agent, which is intermediate oxidation state, that is working as oxidizing agent as well as reducing agent. That is a statement actually. So here oxygen, central atom, here oxygen is the central atom, here chlorine is the central atom, here sulfur is the central atom. Then look at, sir, oxygen here -2 oxidation state, right? Then oxygen here -1 oxidation state. Sir, oxygen lowest oxidation state -2, highest oxidation state +6. Sir, -2 to +6. Which one? For oxygen -2 to +6. Sir, ఇది ఎలా find out చేస్తాం? Group number -8. This is group number. Clear? Right. So lowest oxidation state working as reducing agent. This is working as reducing agent. Then H2O2 in case if you take -1 oxidation state. This is intermediate in between -2 to +6. So this is working as, sir, act as oxidizing agent as well as reducing agent. Clear, my dear students? Then what about this HCl? Sir, HCl in case if you take, sir, chlorine -1 oxidation state to, sir, +7. Sir, +7 is the highest, sir, -1 is the lowest. So -1 is the lowest oxidation state, that is working as reducing agent. Then H2, yes, sulfur 16th group element, -2 to +6 is the oxidation state. So lowest oxidation state here. So lowest oxidation state working as reducing agent, my dear students. So that you have to remember. So which is lowest oxidation state that are working as reducing agent, which are highest oxidation state that is working as oxidizing agent. Come to that. Second question. Which of the following cannot undergoes the disproportionation reaction? So first of all, what is the disproportionation reaction that you have to know? So still now we are not discussed how many types of redox reactions are there. So before going to that, sir, I will explain briefly. So what is the disproportionation reaction? So for example, sir, one of the reaction is there like this: A2 gives rise to, sir, A plus A minus, like this will be there. So look at a single element A. Sir, here oxidation state when it is present in the elemental form 0. Then here plus 1 oxidation state. Then here minus 1 oxidation state. Sir, 0 to plus 1 oxidation takes place. Then 0 to minus 1 reduction takes place. See, a single element, both oxidation and reduction takes place. Sir, oxidation reduction rendu jarigite, then we call disproportionation reaction. Sir, ante ఒకటి ఆక్సిడేషన్ నంబర్ ఇంక్రీజ్ అవ్వాలి, ఇంకొకటి ఆక్సిడేషన్ నంబర్ డిక్రీజ్ అవ్వాలి. క్లియర్? రైట్. సర్, ఇందులో ఏ ఎలిమెంట్ ఆక్సిడేషన్ నంబర్ ఇంక్రీజ్ చేసుకోగలదు, డిక్రీజ్ చేసుకోగలదు? దట్ ఈస్ ద క్వశ్చన్ యాక్చువల్లీ. Sir, first you have to know that oxidation states of each central atom. Chlorine here plus 1 oxidation state, here plus 3 oxidation state, here plus 5 oxidation state, here plus 7 oxidation state. You can find out easily. So by using the previous video we have seen, so by using that method. So plus 7 is the oxidation state for this. So look at this, cannot undergo disproportionation reaction. Why? What is the reason? Because already is the highest oxidation state, ClO4 minus, highest oxidation state. It maybe decreases the oxidation state like ClO3 minus or ClO2 minus or ClO minus. సరే, ఇవన్నీ కూడా అంటే +7 కంటే ఆక్సిడేషన్ నెంబర్ డిక్రీజ్ అయ్యే ఛాన్స్ ఉంది, కానీ +7 కంటే ఇంక్రీజ్ అయ్యే ఛాన్స్ లేదు. సరే, నేనేమన్నాను, ఆక్సిడేషన్ స్టేట్ ఒకటి ఇంక్రీజ్ అవ్వాలి, ఒకటి డిక్రీజ్ అవ్వాలి. సో ఇక్కడ డిక్రీజ్ అయ్యే ఛాన్స్ ఉంది, +5 లేదా +3 లేదా +2, సో లేదా ఎలా. సో దీనికంటే ఇంక్రీజ్ అయ్యే ఛాన్స్ లేదు, బికాస్ సో దేనికైనా గ్రూప్ నంబరే హైయెస్ట్ ఆక్సిడేషన్ స్టేటు, అంతకంటే ఇంక్రీజ్ అయ్యే ఛాన్స్ లేదు. So that's what I told. ClO4 minus disproportionation reaction cannot undergo, so does not take place in that. Clear? Yes, just noted 2 reactions, then 2 more applications we'll see. Yes, look my dear students, here applications of oxidizing agent as well as reducing agent applications will be there. So remember, these applications are very important for the competitive examination. Sir, first of all, strength of oxidizing agent is directly proportional to oxidation state of, say, a central atom, oxidation state of central atom. Then strength of reducing agent is inversely proportional to oxidation state of central atom. So next, third one, strength of acid is directly proportional to oxidation state of central atom, Ca, oxidation state of central atom. These 3 you have to remember. Sir, what are those? Strength of oxidizing agent is directly proportional to oxidation state of central atom. Strength of reducing agent is inversely proportional to oxidation state of central atom. Then strength of acid is directly proportional to oxidation state of central atom. అంటే ఆక్సిడేషన్ స్టేట్ పెరిగితే ఆక్సిడైజింగ్ ఏజెంట్ పవర్ పెరుగుతుంది, దెన్ ఆక్సిడేషన్ స్టేట్ పెరిగితే రెడ్యూసింగ్ పవర్ తగ్గుతుంది, రెడ్యూసింగ్ ఏజెంట్ తగ్గుతుంది. క్లియర్? దట్స్ వాట్ వీ హ్యావ్ టు సీ ద సమ్ అప్లికేషన్స్ హియర్. సర్, హియర్ ఆక్సిడైజింగ్ ఏజెంట్ అప్లికేషన్ అడిగాడు. సరే, ఏంటి సార్, కొన్ని కాంపౌండ్స్ ఇచ్చాడు. సరే వాటిల్లో ఫస్ట్ ఆక్సిడేషన్ స్టేట్ ఫైండ్ అవుట్ చేయాల్సి ఉంటుంది. సరే ఇక్కడ oxidation state of nitrogen, in case if you take here -2 you can get, then here 0 you can get, then here N2, so 2x minus 2 it is equals to 0, then x equals to, so 2 by 2 ante plus 1 oxidation state here, then plus 2 oxidation state here, then plus 3 oxidation state here, then plus 4 oxidation state here, then plus 5 oxidation state here. So all the nitrogen atoms oxidation states we are calculated. Sir, you can calculate by using the previous method, right? So based on oxidation state, I told that oxidation state of central atom increases, strength of oxidizing agent increases. So which is the powerful oxidizing agent in these? HNO3 is a powerful oxidizing agent. Then after NO2, then after N2O3, then after NO, N2O, N2, like this. So this is the order. Next one, again oxidizing agent strength they are asking. KMnO4 central atom manganese oxidation state plus 7, we are already calculated. So K2MnO4 in case if you take plus 6, then MnO2 plus 4 oxidation state, then Mn2O3 plus 3 oxidation state, MnO plus 2 oxidation state. Clear, my dear students? Then what I told, oxidation number increases, oxidizing agent increases. So that's what I told, oxidation number increases, oxidizing agent increases. So this is the order. Then again here HNO3, K2Cr2O7, MnO4 they are given. HNO3, the nitrogen oxidation state is plus 5, right? Sir, K2Cr2O7 chromium oxidation state is plus 6, then manganese oxidation state is plus 7, then plus 7 oxidation state is greater, then oxidizing power is greater, then plus 6 oxidizing power is greater. Clear, my dear students? Right. Next, come to here, strength of acid. Even strength of acid is directly proportional to oxidation state of central atom. So if you take this, so chlorine oxidation state plus 7, then here plus 5, then here plus 3, then here plus 1 is the oxidation state. So I told that oxidation number increases, then strength of acidity increases. This is the order for the strength of acid. Then if you come to there, they're asking reducing nature or reducing agent. Then NH3 minus 3 is the oxidation state, H2S sulfur minus 2 is the oxidation state. Then oxidation number decreases, reducing nature increases. So ammonia is the greater reducing agent. So such type of applications if they will give, so how to do. Then here 2 more exceptions are there. What are those? Sir, just note it, I will do it. Right, so look at. So 2 exceptions are there, so that are not following this order. What are those that exceptions? What are those that exceptions? For example, in case if you take HClO4, HClO3, then HClO2, then HClO. Sir, if they will ask oxidizing agent power, oxidizing agent. So question number 1, sir, order of oxidizing agent if they will ask a question based on it. Then second question, that is H3PO4, then H3PO2, then H3PO3, then H3PO2. If they will take a question on this. So here in case if you take oxidizing agent, even here if you take oxidizing agent. In these 2 exception cases I told. What? Sir, oxidation number is plus 7, then oxidation number is plus 5, then oxidation number is plus 3, then oxidation number is plus 1, like this. Sir, in these 4, oxidation number increases, oxidizing agent nature also increases, I told. But actually, so this is reversely takes place. Reversely takes place. But in case if we take acidic strength is correct order, acidic strength oxidation number increases, acidic strength increases, but not oxidizing agent for this question. Remember, this is a exception. Exception. So why? What is the reason? In detail, we will discuss in the D and F block elements. Sorry, P block elements. We will discuss in the P block elements. Then if you come to there, so here phosphorus, then a phosphorus oxidation state if you find out, then here plus 5, then here plus 3, then here plus 1 oxidation state. I told that oxidation number increases, then acidic strength increases, oxidizing agent increases, oxidation number increases. But actually, it happens like this. So this is most powerful oxidizing agent. Understand all of you? Yes, note it all of you, both questions note it. Yes, look my dear students, now types of redox reactions. In this first one, combination reactions. Sir, what are the combination reactions? Two or more elements combine to form single product. Such type of reactions we are calling combination reactions. Remember, here one of the note you have to remember, that is, sir, in this reaction, one of the reactant must be in the elemental form. In this reaction, one of the reactant must be in elemental form. Elemental form. Sir, element state lo untundi. That's what I told. Sir, what are the examples for these redox reaction? Example number 1, that is, sir, combustion of graphite. In case if you take combustion of graphite, that is a C plus O2, then we call CO2. Sir, carbon oxidation state is 0. Then oxygen, it is present in the elemental form, oxidation state is 0. Then if you come to the compound, I told that according to the definition, 2 or more elements combine to form a single product, right? Yes. Then second note, I told one of the reactant, at least one of the reactant present in the elemental form lo, right? Yes. So now in case if you take, sir, carbon from here 0 to here, oxidation state is plus 4. Then oxygen minus 2, carbon plus 4. So carbon from 0 to plus 4, oxidation number increases. Then what happens? Oxidation happens. Then 0 to minus 2, oxidation number decreases. Then what happens? Reduction happens. So oxidation and reduction both takes place. Then we call redox reaction. Yes, it is one of the redox reaction. Then second example for this, formation of alumina. That is, sir, Al plus O2, 4Al. So then alumina formula Al2O3, so 3O2, right? Yes. So now in the formation of alumina, sir, aluminium and oxygen, sir, both are present in the elemental form. Then oxidation states of this 0. Then here plus 3 oxidation state, oxygen minus 2 oxidation state. So according to the definition, two elements combined, one single product is formed. Then 0 to -2 oxidation state, oxidation number decreases, then we call reduction takes place. Then oxidation number from 0 to +3, then we call oxidation. Oxidation and reduction both are takes place in the reaction. According to the statement, all are eligible. Then these two are belongs to combination reactions. They will ask a question, which of the following is combination reaction? You have to remember, one of the reactant is present in the elemental form, single product will be formed, so that you have to remember. Then one more example, that is rusting of iron. Rusting of iron. Sir, what is the rusting of iron? Sir, Fe 4Fe plus 3O2 is nice to, sir, 2Fe2O3. So this is, sir, 0 oxidation state, 0 oxidation state. Then here +3 oxidation state, here -2 oxidation state. Then iron 0 to +3 oxidation state, oxidation number increases, then we call oxidation takes place. Then oxygen 0 to -2 oxidation state, then oxidation number decreases, reduction takes place. Oxidation reduction ఒకే రియాక్షన్ లో జరిగితే, then we call redox reaction. Then is that combination reaction? Yes, combination reaction. What is the combination reaction? Two or more elements combine to form a single product. Yes, single product. In that, one of the note, what I told, one of the reactant must be present in the elemental form. Then one more example I will give, the combustion of methane or combustion of any hydrocarbon. So look at, my dear students, combustion of methane, in case if you take combustion of methane, combustion of methane, combustion of methane, in case if you take methane, that is CH4, when it is reaction with oxygen, then we know that CO2 plus, then 2 moles of H2O will be formed. Clear? Right. If you balance that equation, then here 2, then 2 to the 4 oxygens. Then here carbon oxidation state is, then X plus 4 equals to 0, then X equals to -4 oxidation state. Then if you come to there, +4 oxidation state. So -4 to +4 oxidation state, oxidation number increases, then we call oxidation. Then here elemental form, one of the reactant is present in the elemental form. Then 0 to, then oxygen -2 oxidation state. Then reduction takes place, decreases, reduction. Oxidation, reduction both are takes place. Sir, one more example, sulfur, when it is reaction with oxygen, sulfur dioxide is formed, SO2. Sir, here 0 oxidation state, even 0 oxidation state. Sir, sulfur from here to there, then in this, what is the oxidation state of sulfur? +4, then oxygen -2. So oxidation number increases, oxidation, then 0 to -2, reduction. So this is one of the example of combination reactions. Understand, my dear students? Yeah, just note it, all of you. Then one more reaction, that is decomposition reaction, we'll discuss. Yes, look, my dear students, second type of redox reaction, that is decomposition reaction. What is the decomposition reaction? A compound break down into simpler compounds, simple compounds are called decomposition reactions. Sir, even here also one of the note you have to remember, that is one of the product must be in elemental form. Elemental form, that you have to remember. For example, in case decomposition of potassium chlorate, in case if you take KClO3, it can be converted into KCl plus O2. It will be decomposed like this. KCl to KCl plus 3O2, like this it will be decomposed. So in this reaction, chlorine oxidation state, in case if you take plus 5 is the oxidation state, you can find out. Sir, plus potassium plus 1, then plus X, then minus 6 equals to 0, then X equals to plus 5. Clear, my dear students? So, chlorine oxidation state is plus 5. Then if you come to there, here minus 1 oxidation state. Plus 5 to 0 oxidation state decreases. Then we call it as reduction. Then oxygen here minus 1 oxidation state. Then if you come here to there, then 0 oxidation state, elemental form. So now it is increases, right? Oxidation takes place. Oxidation, reduction both are takes place. Then a single compound can be decomposed into simpler compounds like this. Then one of the product, what I told, one of the product must be present in the elemental form. Yes, elemental form. Then one more example, that is, sir, H2O, in case if you take H2O, that will be decomposed into, then 2H2 plus O2, like this will be decomposed. Even in this also, if you observe, hydrogen is a plus 1 oxidation state. If you come to their 0, then here minus 2 oxidation state. If you come to their 0, elemental form. So, ఒక కాంపౌండ్ 2 compounds గా డికంపోజ్ అయింది. Then in this, that is minus 2 oxidation state to 0, oxidation number increases, then oxidation, then plus 1 to 0, then decreases, reduction. Both oxidation reduction takes place. Then one more example, sir, mercury oxide HZO, in case if you take, then it will be decomposed into Hz plus O2. It will be decomposed. Sir, here plus 2 oxidation state, here minus 2 oxidation state, here 0 oxidation state, 0 oxidation state. Then Hg plus 2 to 0, oxidation number plus 2 to 0, oxidation number decreases, so that what I told, reduction takes place. Then minus 2 to 0, oxidation number increases, so that what I told, oxidation. According to definition, it is decomposes into simpler compounds. One of the product is in the elemental form. Clear, my dear students? So look at maximum, almost all the decomposition reactions are redox reactions. Then look at, for example, one more example, that is NaH, sodium hydride, then can be converted into Na plus H2. Here Na plus 1 state, then this is minus 1 state. Remember, hydrogen, when it is attached to the metals like alkali or alkaline earth metals, then hydrogen act as hydride state, and minus 1 state lo untundi hydrogen. Maximum case plus 1 oxidation state, when it is attached to the metals, minus 1 oxidation states. Very important it is, you have to remember. Sir, plus 1 nunchi sodium 0 ki veltundi, then minus 1 nunchi hydrogen 0 ki veltundi. Minus 1 to 0, oxidation number increases, oxidation takes place. Then plus 1 to 0, oxidation number decreases, reduction takes place. Oxidation, reduction both are taken. So remember, my dear students, some decomposition reactions are there, that are decomposition of MgCO3 and CaCO3 are not redox reactions. అవి డికంపోజ్ అవుతాయి కానీ రెడాక్స్ రియాక్షన్స్ కాదు. రెడాక్స్ రియాక్షన్స్, నాట్ రెడాక్స్ రియాక్షన్స్. So what are those? Decomposition of MgCO3. So MgCO3 can be dissociate into MgO plus CO2. It will be decomposed like this, Mg plus CO2. Decomposes like that. Then look at, so here magnesium oxidation state plus 2, then here also plus 2. There is no any change in the oxidation state. Then carbon, even oxygen, in case if you take minus 2, then minus 2 oxidation state. Then here carbon plus 4 oxidation state, if you find out, then even here also plus 4 oxidation state. So there is no any change in the oxidation states of elements. So that's what I told. Then it is not redox reaction. This redox reaction kaadu. It is not redox reaction. Even CaCO3 can be decomposed CaO plus CO2. Oxidation states ఏమీ చేంజ్ అవ్వట్లేదు, అందుకోసం అనేది redox reaction కాదు. Yes, it is not redox reaction. Clear, my dear students? Then we'll discuss one more. Just note it all these examples. Just look all of you, my dear students, that is a disproportionation reaction. Third reaction, third redox reaction, it is disproportionation reaction. Sir, what is the disproportionation reaction? The reaction in which same element undergo oxidation as well as reduction. For example, here the three examples are there. What are those? Then first example, in case if you take here the phosphorus P4 state అంటే elemental state లో ఉంది, దాని oxidation state 0. సరే ఇక్కడికి వచ్చేసరికి pH3 లో phosphorus ఉంది, then NaH2PO2 లో phosphorus ఉంది. That's what I told, same element. సరే ఈ phosphorus oxidation state మనం ఫైండ్ అవుట్ చేస్తే దీనికి -3 వస్తుంది, దీనికి +1 oxidation state వస్తుంది. కావాలంటే మీరు ఫైండ్ అవుట్ చేయండి సార్ బై యూజింగ్. సో ఫస్ట్ వీడియోలో కొన్ని మెథడ్స్ చెప్పాను కదా, ట్రిక్స్. సార్ ఆ ట్రిక్స్ యూజ్ చేసి మీరు ఫైండ్ అవుట్ చేయొచ్చు. సరే ఇక్కడ 0 నుంచి -1 ఆక్సిడేషన్ స్టేట్కి వెళ్తే దెన్ వాట్ ఐ టోల్డ్ ఇస్ దట్ డిక్రీజెస్ ఆర్ ఇంక్రీజెస్? డిక్రీజెస్, రిడక్షన్ టేక్స్ ప్లేస్. దెన్ 0 to +1 ఆక్సిడేషన్ స్టేట్కి వెళ్తే దెన్ ఇంక్రీజెస్, ఆక్సిడేషన్ టేక్స్ ప్లేస్. సో ఒకటే ఎలిమెంట్ ఆక్సిడేషను రిడక్షను జరిగితే, ఆక్సిడేషను రిడక్షను జరిగితే దెన్ వీ కాల్ ఇట్ ఈస్ disproportionation reaction. Disproportionation reaction. Then even here chlorine, in case if you take chlorine is present in the elemental form 0, then NaCl in this -1 oxidation state, chlorine -1. Sir, NaOCl, sir, chlorine, sir, +1 oxidation state in this case. Clear? So +1. So 0 to -1 oxidation number decreases, reduction. Then 0 to +1 oxidation number increases, oxidation. Oxidation and reduction both are simultaneously takes place. Then if you come to there, bromine 0 oxidation state, then KBr, Br -1 oxidation state, here +5 oxidation state. Then 0 to +5 oxidation because oxidation number increases. Then 0 to -1 oxidation number decreases, then we call reduction takes place. So single element both oxidation and reduction takes place. So such type of reactions we call disproportionation reactions. ఇవన్నీ కూడా disproportionation reactions అంటాం. So what is the definition for this? The reactions in which both same element both oxidation and reduction simultaneously takes place. Is called disproportionation reaction. This is disproportionation reaction. Then next we have to discuss about the comproportionation reaction. So note it all of you. So look, my dear students, one more reaction, that is comproportionation reaction, the fourth type, redox reaction. So look at some of the examples are there. I will explain examples first. So here two species having the same element but different oxidation states. So look at two species with the same element in two different oxidation states. Two species having same element with two different oxidation states form single compound, a single product. So here 0 oxidation state because of elemental form, here +4 oxidation state, two different oxidation states. Then here if you come +2 oxidation state. So one is +4 to +2 oxidation number decreases reduction. Then 0 to +2 oxidation number increases, then oxidation. Then if you come to there, CuCl2 +2 oxidation state here, Cu 0 oxidation state here. Then Cu2Cl2 +1 oxidation state for copper. 0 to +1 oxidation. ఎందుకు ఆక్సిడేషన్ నంబర్ ఇంక్రీజ్ అయింది. +2 to +1 decreases reduction. Oxidation number decreases reduction. Then if you come to there, AgSO4, Ag +2 oxidation state, Ag here 0 because it is present in the elemental form. If you come to there, Ag2SO4, so 2 plus, then here +1 oxidation state. So +2 to +1 oxidation state, oxidation number decreases, reduction. Then 0 to +1 oxidation number increases, oxidation takes place. So remember once again, two species with the same element in two different oxidation states, two species with the same element, two species with the same element in different oxidation states, different oxidation states to form single product. So it is like a combination reaction, but here the same element is there, so both will be combined, same element will be there, so single product will be formed. It is like a combination but not combination, it is comproportionation reaction. Understand, my dear students? Then one more reaction is there, just note it, we will discuss next reaction. Yes, look my dear students here. So this is the fifth most important of redox reactions, very important. Displacement reactions. In that again metal displacement and non-metal displacement, two types are there. First, metal displacement. So here, so you have to remember, so more active metals displaces less active metals in its salt solution. Remember, understand. So look at statement, more active metals, less active metals. ఇది మనకు ఎలా తెలుస్తుంది? So you have to remember that electrochemical series we are seen already. This is reduction potential values. Sir, increasing the reduction potential values based on that reduction electrochemical series we can arrange. ఈ electrochemical series లో top to bottom, this is the top to bottom, again top to bottom activity decreases, that is reactivity decreases. ఇది మనం ఆల్రెడీ electrochemistry లో నేర్చుకున్నాం. In electrochemistry we are already discussed about it. Activity in the electrochemical series top to bottom decreases. So for example, in this reaction zinc copper both in case if you take, so zinc here it is there, then copper next here it is there, then which is the below will be there, that is less active when comparative to zinc. So zinc is the more active metal that can displace less active metal in the salt solution. that is called displacement reaction, metal displacement. Even here also iron and aluminum both in case if you take. So you have Fe, iron here, then aluminum here. Look at, observe it carefully. So aluminum is the most active than that of iron. So that aluminum can displace iron. Here zinc is most active, so that's what? Zinc can displace copper. That is we are calling the displacement reactions. Metal displacement reactions. So ఏవైతే పైన ఉన్నాయో సిరీస్ లో అవి యాక్టివ్ మెటల్స్. సో డౌన్ ద గ్రూప్, డౌన్ ద సిరీస్, then activity decreases. So based on the electrochemical series, we can say that is. Understand all of you? Yes, note it all of you this reaction. Then we'll discuss non-metal displacement reactions also. So look my dear students, in this, in the metal displacement, non-metal displacement reactions we have to discuss. So that is, sir, what is the non-metal displacement? In the previous session and the previous reaction, metal displacement అంటే metal place లో metal వచ్చి displace అవుతుంది. ఇక్కడ metal place లో నాన్ మెటల్ ప్లేస్ లో మెటల్ వచ్చి డిస్ప్లేస్ అవుతుంది. సార్ ఫర్ ఎగ్జాంపుల్ సోడియం ఇన్ ద H2O, యాక్చువల్గా H2 ఎలా ఉంటుంది సార్? ఆక్సిజన్ అటాచ్డ్ విత్ హైడ్రోజన్. Sir, one of the hydrogen replaced by sodium, then NaOH will be formed like this. The sodium displace out on the hydrogen place load. So look at, I told that previous most active metal displaces less active one. So ikkada hydrogen, the above all metals which are there that are most active and comparative to hydrogen. So remember my dear students, all these are displaces the hydrogen atom in the water molecule. So water లో ఉన్న హైడ్రోజన్ ని పైన ఉన్న అన్ని మెటల్స్ డిస్ప్లేస్ చేయగలవు. దట్ ఈస్ ద రియాక్షన్స్ ఆల్ దీస్. So in case if you take sodium displaces hydrogen, NaOH will be formed. So look at in this zero oxidation state here, oxygen in case if you take hydrogen in case if you take, then +1 oxidation state. So sodium 0 to +1 oxidation state, then +1 to 0 oxidation state. So +1 to 0 reduction, then 0 to +1 oxidation. Oxidation, reduction both are simultaneously takes place. Even here also 0 oxidation state. Then here +3 oxidation state. Then hydrogen +1 oxidation state. Here 0 oxidation state. +1 to 0 oxidation state. Oxidation number decreases, reduction takes place. Then 0 to +3 oxidation number increases, oxidation takes place. So that what I told, oxidation reduction both are takes place, and at the same time, sir, metal is displaces the non-metal. Reason is in the electrochemical series, sir, hydrogen above whatever the metals are there, that can displaces. That can displace. Clear? So at last two, in case if you take, even here also metal displaces the hydrogen. So look at then MgOH taken twice takes place. Here 0 oxidation state, +2 oxidation state, then hydrogen +1. Then if you come to there 0, so 0 +1 to 0 reduction takes place. Then 0 to +2 oxidation takes place. Then if you come to there F2, it is 0 oxidation state. Remember in the electrochemical series top to bottom, sir, least case and last undedi manak fluorine. Fluorine act as a oxidizing agent. Then lithium act as a reducing agent. Reducing agent ఏం జరుగుతుంది? ఆక్సిడేషన్ జరుగుతుంది. దెన్ ఆక్సిడైజింగ్ ఏజెంట్ రిడక్షన్ జరుగుతుంది. రివర్స్ కేస్ ఆక్సిడైజింగ్ ఏజెంట్. సరే ఇఫ్ యూ లుక్ ఎట్ దేర్ ఇట్ విల్ బి అండర్స్టాండ్ ఇట్ ఈస్ యాక్ట్ యాజ్ ఏ ఆక్సిడైజింగ్ ఏజెంట్ అయితే. ఆక్సిడైజింగ్ ఏజెంట్ ఏం జరుగుతుంది? రిడక్షన్ జరుగుతుంది. ఇది రిడక్షన్ జరిగిందా లేదా ఎలా తెలుస్తుంది? సార్ 0 to -1 oxidation state. From here to there oxidation number decreases, so reduction takes place. ఏదైతే రిడక్షన్ జరిగిందో అది ఆక్సిడైజింగ్ ఏజెంట్ గా వర్క్ అవుతుంది. Sir, remember my dear students, the fluorine is a powerful oxidizing agent when compared to all the elements. Okay, clear? So then next video I will discuss about what are those how to balance the redox reactions in two methods. One is ion electron method, off reaction methods. So two methods are there, oxidation number method, ion electron method is there. So two methods we'll discuss. So thank you very much. Then subscribe and share my videos to all those are preparing for the JEE mains and NEET examinations. Thank you very much.